So, real quick, me. Casey Faist, first of her name, mother of snakes, at Heroku. If you have questions, compliments, or complaints about deploying to Heroku, I am all yours. Come and find me. Another pastime is making friends with designers and conning them into making the most adorable snake logos. So I'm open to questions on both of these subjects after the talk. Okay, this talk is labeled Everything You Want to Know, but We're Afraid to Ask About Data Classes. So I'm going to set the scene. We're going to go on a little journey together to build the empathy for what exactly that means. So you're at your local Python meetup. You have pizza. You're sitting there listening to a talk or a lightning talk or working on a project, and somebody rolls up to you. Data classes, they say. Data classes, they say. Somebody else comes over and is like, oh, they're awesome. Have you used them? Have you tried them? And if you're anything like me at this point in the story, you have like this piece of pizza just hanging out of your mouth, and you're like, what? Data classes are what I've seen at meetups and kind of in talking to people. Is they're not a complicated feature. They're not a complex feature, but they're difficult to wrap your head around without the proper context. Like, what are they for? You know, where did they come from? Why? Is it a class? What are we dealing with here? And I don't think I was the only one who kind of noticed or felt a little surprised by these. So let's kind of unwrap the story a little bit. At this stage, you're at the perfect step for your journey towards data class knowledge, because we now have recognized that we don't know what they are. Excellent first step. So with a subject like this, all the Python features that roll out, they have PEPs, they have blog posts, they have context and Twitter discussions and all of this content, and kind of sifting through. How do you sift through? What are you looking for to kind of get that context? For me, when I try to do this, it always starts with somebody had a question or a pain point. Somebody needed something, and that's where this came from. So after a little bit of digging, I ended up finding a Stack Overflow post. Surprise, surprise. That's 4 years old. It's got 400K views. It's been going on for years. There's just tons of content. And the question is this: is there a way to conveniently define C-like structures in Python? That's it. The field type has been available since Python 2.7, but this discussion went on to talk about all the weird and kind of wonky and just not quite right ways that people have solved this problem in the past. My experience with C is somewhat limited, but looking at this thread is really informative for me as a Python developer, trying to wrap my head around what this new feature is. Previously, the named tuple was considered one of the best ways to address this specific need, or a good way. I know we only have one way of doing things in Python, but this is not the only thing you could want. It's a little bit inflexible. It's immutable. There are different needs you could have of a data store like a C struct. And when this post, back last October, as of last October, this post was updated with, hey, this is the answer. If you're looking for a C struct in Python, a data class is that. It provides you flexibility. It syncs with the typing module. It plays nicely with a lot of the new features kind of rolling out around attributions and all that stuff. So try this one. Okay, some context. Is there more? I don't have the C background, so that wasn't quite enough for me to sink my teeth into this. Indeed, there are more layers to this problem. There's another thing that was discussed as part of the data classes release was wanting JavaScript dot notation. I know, blasphemy, but right now, if you want to use a dictionary, you want to assign something, you create your dictionary, then you have to use this bracket quote syntax, right? If you are familiar or have used pandas, you know that they kind of do some magic to get around this and use dot notation, and it's kind of nice. It's just like a nice to have, right? The equivalent in JavaScript, I know, avert your eyes if necessary, you get that object dot cat, gives you directly what you need. It's just nice, right? We can have nice things, right? Another important piece of context, and the closest down this chain, is the adders project. Who's familiar with the adders project? Cool, all right. This means I can share something exciting. That's awesome. So the adders project provides a way to boilerplate your classes. So you have a regular old class, you've defined it, and you would like some boilerplating around equality or hashing or X number of things. Dunder boilerplating, essentially. And I actually found when I looked at their documentation, they have a really good discussion on the why not page of that website. So if you're interested, go there. And they actually talk about, like, why would you not use a tuple or a name tuple instead of the adders project? And because data classes are based on, the implementation is based on the adders project, the reasoning kind of transfers. So why would you use a data class instead of a name tuple? Some of the reasons are readability, sharing code, the clarity, the explicitness. So if you're curious about that, go check it out. The first time I gave this talk, I realized that I didn't actually describe what a Dunder method is, even though this is a central point to what a data class is giving to you. And I wanted to take a step back and clarify this. So a Dunder method is, and I didn't hear it pronounced out loud until far too late, so it is Dunder, which is very fun. You have a method that is on top of a class, and you have 2 underscores. So if you ever write if name equals main, with the 2 underscores on each side, those are Dunders. And what Dunders do in Python, very high level, where this is not a Dunders talk, but they provide some of that magic that lets us type at a high level and get compiled down to C, and massive errors do not occur. Like, it knows roughly what to do if you try to compare, if you try to concatenate, for example, a string and an integer, it will know to make them both strings and put them together and give you a new string back with what would be that int, right? That happens because of Dunder magic. It's a deep dive, but it's important for this because in some cases, you end up writing, if you hit these specific bugs that we're going to talk about, you hit them and they're very frustrating and they're small, but it could be better. And now it can be, very easily. Oh, just an example. Name equal repr. Those equal and repr are going to be important here in a second. Okay, so we've gone through some layers. We have just a little bit of context on where this has come at us from. Now let's put it together. Why not the other tools in our current Python toolkit? What does this add to our current set? This is all cool, but what does it do for us? Before data classes. An example. So I would like to make a wallet. I'd like to make a class wallet. And I needed to do a few things that you would expect a wallet to be able to do. I want it to be a class, so it can inherit, it can use any kind of special class things that I need to do. It contains coins. It has qualities that likely won't change, and it has a total amount. I would like my wallet, my very special wallet, to tell me exactly how much money is in it at one time. So let's write this. What would this look like as a class? Starting off, kind of checks out. You need to define an initialization. You need to set all of these attributes on your class. And then we have a custom function for the amount in the wallet. And that is just, it's a long line, but it's just nickels times 5, dimes times 10, pennies times 1, because explicit, and then divided by 100 because dollars, not cents. So this is where you might start. But after a while, you might hit some problems. For example, if you are working with a class and you want to be able to compare wallets, so you have Casey's wallet over here and Veronica's wallet over here, you'd like to be able to compare. Do they have the same number of dimes? Do they have the same number of pennies? It is occasionally helpful, because of hashing, and we'll get to this in a second, to actually define your own equals. This is another one of those magic classes, and Python allows you to reach down and make your own magic Dunder methods that enforce a specific way for this to happen. And essentially what this does, it allows you to say, my wallet.nickels is other wallet.nickels, and it'll give you a Boolean in return. Okay, that's allowing that to happen. This gets a little bit tricky though, because remember, this is mutable. Name tuples, using a tuple for this, is immutable. And because it's mutable, our hash could potentially change. So our equals can get wonky. This can lead to variables that look the same, but are not, because their pointers are in different locations, because your hash is an integer. So because of that, you might find that it's necessary for this class to enforce this behavior. You keep hitting this bug with a specific part of your API over here, and you just need it to behave reliably. So let's add that. And then also, the text is getting small. I apologize. But when you call the values of your, if you're trying to print one of your values, say you want to know how many pennies are in your wallet, there is behavior with the repr function, not the Dunder repr, but the regular repr function, where it will give you back double quotes. So you'll get 1 for pennies. Say we have 1 penny in our wallet, you'll get quotes and then double quotes. And for parsing, this is kind of annoying, right? It's not the end of the world, but you'll find yourself across your code base just like countering for that. So say you want to cut it off at the source, and you define your own overriding Dunder repr method. These are niceties. We just went through a lot of work for like things that are just kind of nice and just kind of, you know, nice to have and like nice to use. After CPython data classes. So this is the PEP, and I'm bringing this up just because I found it really helpful actually when going through this. There's a lot of text up there, but the key points are it's a mutable name tuple with defaults. You create a data class the same way you'd create a regular class and add a decorator. This decorator, it's literally called just @data classes, provides generated, auto-generated methods. So that's code you don't have to write. It initializes your class for you. It overwrites that repr, so you'll get printed lovely strings out, and you can use that dot notation more effectively. And you automatically get those comparison methods, and optionally more. You can optionally freeze your data class and make it immutable. You can optionally, there's a lot actually of different options you can pass in that data class's parameters list. Taking a big step back, A normal tuple looks like this. You use the parentheses, and then you get something that you can reference by index. Immutable, except when it's not, as discussed by Al Swigert. Another talk I recommend. A named tuple, kind of similar to what we're functionally, the shape of it is somewhat similar. You can create a named tuple called wallet. You can give it a name, which is that first parameter. And then you can tell it that it has named categories within that tuple. And then when you use the wallet kind, because it's an inheritance pattern here, you get a my purse, and you can set dimes, and you can see that that's 3. So that gives you that dot notation and the categories. And it's simpler. It's a simpler way to kind of get at that function, right? And there are some defaults that allow you to kind of play with what the name tuple can do for you. There are a lot of cases where this is the right choice. But if you need more flexibility, you need more control, you need it to be explicit, then there are data classes. So let's make one. Let's make a data class here. We start same way we'd start any class definition, with class, my wallet, my generic container, so we can inherit, and docstrings to describe my class. The next step, you add that data class decorator, and then you can give it directly what your fields are going to be. In data classes, we call these attributes fields. You'll see in a little bit they expand to have their own kind of special data class fields category. And you can use the class attributes, function attributes, and the type attributes from the get-go. Much quicker. We have initiated our class. Done. Next, I'd like that custom function. So we're going to define the mountain wallet. It's the same function. We just stick it in. Completely valid. This is actually available in 3.6 as well. You can backport it using from data classes, import data class. It's in standard lib from 3.7 on. So if you're pre 3.7, this is what you'll need to do, and it'll work exactly the same. Now, one thing that the standard library does not provide is a way to look at what this generates. But there is a handy package that will. If you start playing around with data classes and you're like, what is this generating on the back end? What is the code actually going to run? There's a package by Damla Altun. And this package will take your data class and inspect it and print out the code that it's generating on your behalf that you don't have to think about. And I apologize for this next slide, but it's a lot. But look at all this code we didn't have to write. Look at this. We have our cleaned up repr. We have equals. We can optionally have greater than, less than, equal to, all those other comparisons. Yeah, this is a lot of work done for us. This is nice. This is a nice thing. We have a nice thing here. Yeah. There are always some gotchas, and this is no exception. Inheritance is just a little bit different than you might expect. So if you're going through, you're making data classes, and you have data classes inheriting from data classes, it might be just a little bit different. This is from the abstract, but to highlight, it starts at your target object, and it goes backwards. And the way that it inherits the different fields, these attributes for your classes, it will overwrite with the newest, yes, it'll override the base class fields, which may or may not be what you want. Be aware. In most cases, that's not going to, you know, it's an edge case thing to remember if you start seeing something weird. this is an example of that behavior. This is directly from the PEP. You can go, I just reformatted it so it was obviously easier to see with a dark background, but essentially it will overwrite that later integers if you're reusing. Just be aware. A cool thing, though, that this allows you to do, but does not automatically provide, is the Dunder slots method, which is memory optimization. This allows you to very easily, because we're writing so much less code, you're going to just stick it in there. It's still explicit what the class is trying to accomplish, but it allows you to say, hey, data class, take these data fields and don't always load them into RAM, stick them down, and only call them up when needed. It optimizes at that level. I'm not a slots expert, but it is, it looks a lot cleaner to me than other implementations I've seen. I think that's a strength here. But you have to do it yourself. Cool. How do we use them? So data classes are not ideal if you have a class that needs to do lots of transformations and a lot of heavy lifting on the data that you're passing it. This is essentially a state object. You have a piece of information about what should happen or what the current state of an API call is or what the current state of X process in your application. This is a good way to kind of pass that around and either mutably update it or immutably track it. It's customizable, so name tuples, there's an argument to use them in a similar way, but you can get a lot more fine-grained with how you're using these in your applications. And they're a time saver. It's a lot of code that you just get for fun. It's kind of case study. All right. We have just 5 minutes, so I'm going to bring this up. But Pursued PyBear is an open source game engine that is using data classes as the event system. So they have a game loop. They go through and each data class creates an event in an action that should happen in that game loop. And let me see if I can make this big enough to see. That is not bigger. Ah! Okay, it's bigger now. Ah! Too much. Okay. There we go. Okay. So you can see this is compatible with 3.6. So they're importing. But you come down here. So in this case, a button was pressed. Button. It's a mouse button. It's got a position. It's got a scene on which it's a base. When the button's released, same thing, updates. Start scene. So these are all, if you're not familiar with game development, these are processes that might take a little bit more orchestration. There might be, JavaScript has this idea of listeners, that you're listening for events and things like that, but this allows you to kind of have an active system. So one cool way to use data classes in your project. Now my presentation, okay, no, we're good. It's where the presentation was going to be huge too. All right, go get classy, y'all.
In the definition for the type classes, there is the syntax you were showing has type annotations.
Yes.
Is the type annotation enforced in any way, or is it just there for documentation purposes, or what role does that play?
Gotcha. So it is not enforced. This is concurrent with static typing in Python. The plan is not that core Python is going to enforce this ever, and this does not conflict with that. It allows you to use a static typing enforcing system, like MyPy or something similar, to in this case, you could like enforce it on your data classes to have an extra layer of validation, make sure the data that you're passing around is correctly typed, giving you the output you're expecting, all that stuff. So not enforced, optional, also nice.
Optional in the sense of you don't have to annotate at all, or that you have to annotate with any, I honestly don't care, it's just going to be stuff.
You know, I haven't written any without annotations. So let me do that, and I'll let you know if it blows up.
Any more questions? All right. Ms. Casey will also be available outside in the hallway if you wanted to have longer conversations. Let's give her another round of applause.